I welcome you to today's class as we continue with our study on electricity. And in today's class, we are going to look at the cost of electricity. We have just two objectives we're going to cover and we close the class. The first objective is to define a kilowatt hour and understand it as a unit of energy. Once we understand that a kilowatt hour is a unit of energy, we are going to use it to calculate the cost of electricity. So let's quickly dive into the first objective. Now, you need to understand that a kilowatt hour is a bigger unit compared to a joule. I'm sure you are used to a joule, but the problem is a joule is a very small unit of energy when we are dealing with the consumption of electrical energy. We end up having very large numbers, and to manage the numbers, a kilowatt hour is used instead. Now, what is a kilowatt hour? It is the amount of energy that is used when a gadget rated 1000 watts is run for an hour. A gadget rated 1000 watts is run for an hour. The energy which is going to be used in that time is what we call a kilowatt hour. Maybe to understand the relationship between a kilowatt hour and a joule, let's say energy is equal to power times time. Now we are saying the energy used when a gadget rated 1000 watts is run for a time of 1 hour. 1 hour is 60 minutes times 60 seconds, which is going to give us 3,600,000 joules. Honestly, this is a very, very big number. So instead of using a joule, we are going to use a kilowatt hour, because 1 kilowatt hour is equal to 3.6 times 10 to the power 6 joules. From this calculation, 1 kilowatt hour is energy used when a gadget rated 1000 watts is used for an hour. So this is just 1 kilowatt hour, and that 1 kilowatt hour is translating to 3.6 times 10 to the power 6 joules. So in all our workings, when we're calculating the cost of electricity, we'll be using a kilowatt hour. Any energy given in joules, convert it to kilowatt hours. Any power given in watts, convert it to kilowatts. Any time given in seconds, days, years, convert it to hours, because our unit of energy is a kilowatt hour. Time in hours, and power in kilowatts. That's what we'll be doing. Let's calculate the cost of electricity. How then do we calculate the cost of electricity, since we now know a kilowatt hour? When you're calculating the cost of electricity, there are three basic steps you need to go through. The first thing you need to do is to convert all power ratings to kilowatts. If a gadget is rated in watts, the first thing you need to do is to convert it to kilowatts. We need to find the kilowattage for each gadget. Step number 2, once we find the kilowattage, the next thing is to find the energy consumed by a gadget. And we know that energy is equal to power times time. But our power is in kilowatts and our time is in hours. So we're going to convert all times to hours and all power ratings to kilowatts. Once we multiply power times time, power in kilowatts, time in hours, we're going to find the units of energy used during that time in kilowatt hours. Once kilowatt hours are found, we go to step number 3, calculating the cost of electricity. A kilowatt hour is the unit for electricity. So we'll say the total cost of running a gadget is the number of units, how many kilowatt hours were used, times the price per unit. then we end up finding the cost of electricity. Let me quickly use an example to demonstrate what I'm talking about. Here is a question. A light bulb of power rating 100 watts, so we have power rated in watts, is used for 7 hours. What is the cost of the electrical energy used if the price per unit is? We are trying to say 1 kilowatt hour is equals to 80 cents. So we want to find the cost of using this gadget for 7 hours. Step number 1 is to convert the watts to kilowatts. Because our energy was given in watts, we want it in kilowatts. We divide by 1,000. A kilo is just 1,000. Revisit conversion of units if you're having a problem. So we divide the given power, 100 watts, we divide by 1,000, and we end up getting 0.1 kilowatts. So the power rating or the kilowattage is 0.1 kilowatts. This rating here, we don't want it in watts, we want it in kilowatts. Now, step number 2, once we find the kilowatt rating, we now find the energy consumed over the 7 hours. We know that energy is power times time. Remember, our power should be in kilowatts, our time should be in hours. We have calculated the power rating on step number 1 here. So we take this 0.1 kilowatts and we use it as our power rating. And they said the time taken was 7 hours. We multiply by the hours in which the appliance was in use. And we're going to find the energy of 0.7 kilowatts hour. These are now what we call units. These are the units consumed during the 7 hours. Finally, we will now calculate the cost of electricity. We have the units consumed and we have the price per unit. Each unit is costing $0.80. How much money will be paid for using this bulb for 7 hours? The number of units consumed times the price per unit will get 0.56 US dollars. With this, we can safely say we have found the cost of running a bulb rated 100 watts in running it for 7 hours. Now, I want to give you this as we go for a commercial break. The question which I'm going to use as example number 2. Attempt to solve it, after which I'll come after the break with the solution to the answer. Then you compare with your answer. Enjoy the activity. You are welcome back. Now, let's dive into the solution for example 2. Step number 1, we said the first thing is to convert the 60 watts to kilowatts because we're dealing with a kilowatt hour. We want all the power rating to be in watts. How do we convert 60 watts to kilowatts? Divide 60 by 1,000. So this is the power rating in kilowatts. This is the kilowattage. Once we find the kilowattage, we go to step number 2. Step number 2, we're actually finding the energy consumed or the units which are used over the time described. The light bulb is used for 312 hours in a month. Every month it runs for 312 hours. What is the cost of running the security light per annum? Per annum it's per year. These are 12 months. We are going to say electrical energy is power in kilowatts times time in hours. Where are we going to get our power in kilowatts? We calculated it here on step number 1. So we take the 0.06 kilowatts, we put it on the power in kilowatts. The time they said is 312 hours per month, but we are looking for the cost per annum, and we know that an annum has 12 months, it's a year, which is times 12 months. So we're going to say 312, which is used per month, times 12 months in an annum to get the total units. These are now the units which are consumed during that year. So in a year, we use 224.64 kilowatt hours. Once the number of units are found, we go to step number 3, where we calculate the cost of electricity. The cost of electricity is very simple. If an orange is costing $2, what about 12 oranges? That's the ratio we're using here. They said each unit, each kilowatt hour costs 0.80 cents. What about 224.64 kilowatt hours? That's a straight ratio. You multiply the number of units by the price per unit. How many units are used per annum? 224.64 kilowatt hours times the price per each unit. We are going to get $179.71. Make sure that your money is always to 2 decimal points. When you're calculating money, put 2 decimal points. So the cost of running that security light over a year is 179.71. Before I leave you with a practice question, let me emphasize, make sure your power ratings are in kilowatt hours. Make sure your time is in hours. Power rating, kilowatts, time in hours. Then the units which are used, the units you see on your meter at home, they are kilowatt hours. So the price per unit times the number of units, we're going to get the total price. I'll leave you with this question for your practice. Enjoy your practice. Signing out is your senior coach, Chigo. See you next time.